So now we're going to talk about reflectional symmetry and translations. Reflectional symmetry is basically just like the symmetry that you would see in art. So reflectional symmetry basically says if I draw a line down the middle, or really just anywhere, or anywhere in our case, the shape will be the same on both sides. Okay, so let's take a look. Well, I can draw a line down the middle of this triangle here, and that's called a line of symmetry because it's going to fold over onto itself. Now, I can also draw a line here, and I can draw a line through here. Each one would act as a line of symmetry because each time they're going to fold over on themselves. And a lot of the times when you have regular polygons, you can kind of tell by just adding up the number of sides or points. So like 1, 2, 3, there'd be 3 lines of symmetry. There's 5 pointed stars, so there's going to end up being 5 lines of symmetry here, all through the points. So we got 3, and we got 5. Okay, then I got my nice hexagon here. And it's going to be the same thing. There's 6 sides, so it ends up being 6 lines of symmetry. Six lines of symmetry. Okay. This one's pretty unusual. There's actually 2. You can put one right down the middle just like this, and it folds over itself, and you can put one right through just like this, and it folds over itself. And that gives me 2. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there should be 16. So 1, 2, 3, 4, 5, 6, 7. Hold on. 8. Wait a minute now. Okay, so it'd be 9, 10, 11, 12, 13, 14, 15, 16. So that one's a little bit hard to draw, but there's 16 there. So that's a line of reflections. And I paired this in class with translations because both kind of really small topics to look at. So that was lines of reflection, and then we have a translation. What a translation is it is a slide. So when I translate, I am sliding an object to another position. So if you ever seen that thing called the cha-cha slide, it really should be called the cha-cha translate. At any rate, all I have to do with a translation is just simply add the vector to it. So this is considered a vector. So that's considered a vector. So what I'm going to do is just take the points and add to the vector. So I got W is 1, 5, or rather add the vector to the points. So those are my points. All I'm going to do is add the vector. So let's see. 6, no, 7. Silly of me. Let's see. 2, 6. 5, -1. And 0, -5. So I'm literally just adding. And that's how I get my new points. Okay. Same thing. Oops, my vector now is 4, -3. Mustn't get that wrong. Okay, so then I just add across again. 1 plus 4 is 5. 5 plus -3. Oh, that's -4. Oops, I made a mistake. -4, -4, -4, -4. So 1 plus -4, let's get rid of that. 1 plus -4 is -3. 5 plus -3 is 2. -3 plus -4 is -7. 4 plus -3 is 1. 0 plus -4 is -4. -3 plus -3 is -6. -5 plus -4 is -9. -7 plus -3 is -10. Okay, and then finally, WAVE, I'm going to add -5, 3 to it. To all of them, and so I'm going to get -4, 8, -8, 7, -5, 0, -10, -4. There we go, just adding straight across. Good. Okay, so last kind of part of this here is this. Now there's no extra shape to translate. I didn't do that. I just want to see what the vector is. So I want to see what the vector is that goes from one place to another. Now you can do this one of two ways. Either you can look at A to A prime. So A in this case would be, so here's A. That would be 2, 2. A prime would be -3, -4. Okay, and you're gonna ask yourself, well, what do I have to add to add the 2 to get -3? And the answer would be -5. 2 plus -5 is -3. And what am I going to add to 2 to get -4? And again, the answer would be -6. Because 2 plus -5 is -3. And 2 plus -6 is -4. Or coincidentally, you could just also count. So you could go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And that will also give you your vector. You got to remember that the x controls the left, the right. And you got to remember the y controls the up and down. Negative would go down, positive would go up. And you also have to make sure you realize that, again, like I mentioned in the last video, A is the pre-image, A prime is the image. So you want to make sure that you look at that as well. Same thing here. If I just count and go 1, so A is my, oh wait, hold on. A is my pre-image, so that's my pre-image right there. And then A is my image. We're going to get 1, 2, 3. 1, 2, 3, 4, 5. And we're going in positive directions, so 3, 5 is my vector. Okay.